Today we're going to talk about working with exponents and then working with polynomials. So I want to start by just reviewing how exponents work. If you want to evaluate 3 to the 4th, that means you're multiplying 3 by itself 4 times. 3 times 3 is 9, and 9 times 9 is 81. We say that the 3 is the base, and the 4 is the exponent. We always assume that exponents apply to the thing just to the left of them, unless there's parentheses to include more in the base. For example, in part B, when you have the parentheses, that actually means -5 is the base. So in this problem, we're taking -5 times -5, and that would give me a positive 25. However, if there aren't parentheses, the negative is not part of the base. The negative is just in front of the problem, and the only thing we're squaring is the 5. So this is a -5 times 5, which actually gives us a different answer. We end up getting -25. So we need to have parentheses if we want to include that negative in the base. Now, before I give you our laws of exponents, I want to define the 0 exponent. And the definition of the 0 exponent is anything to the 0 power is 1. So, for example, 5 to the 0 is 1. Now, you do have to be really careful about what exactly is the base. And so -3 to the 0, the negative is not part of the base. We're only taking 3 to the 0. 3 to the 0 turns into a 1, but then that negative stays there, and the answer is -1. The same idea is true in part C. We've got a 5 times x to the 0. The 0 exponent only applies to the x. So the 5 stays there, x to the 0 is 1, and my final answer would be 5. Whereas if I have parentheses around the 5x, the entire thing is the base, and that means my entire answer is 1. Now in this section, we're going to learn a couple different rules for working with exponents. If the bases are the same and you want to multiply something with exponents, you always add the exponents. For example, this product rule is telling me that 2 to the 4th times 2 to the 3rd would be 2 to the 7th. Notice the 2 doesn't change, the base doesn't change. We just add the exponents. We can understand why this works by writing out the problem. 2 to the 4th means there's 4 2's being multiplied together. 2 to the 3rd is 3 2's, and you can count, I've got a total of 7 2's here, or 2 to the 7th. Now, we can multiply in any order we want, and so as you start to see both coefficients and variables in a problem, you can multiply, say, the 3 and the 4 together, and then you can do the y to the 4th and the y squared. You can multiply in any order you want. So 3 times 4 is 12. But then to multiply with exponents, we add the exponents, and we would get y to the 6. Same idea in part C. I've got an x to the 1. If there is no exponent, there's an imaginary 1 there. I'm going to multiply that by the x to the 5th, and then I'll take the y squared and multiply that by the y to the 11th. To multiply, I add the exponents, so that gives me an x to the 6th and a y to the 13th. Now, in these problems, the distributive property still holds. So if I want to multiply by a sum or a difference, I can distribute the 2x to the 3rd. I'm going to take 2x to the 3rd times x squared, and then I'll take the 2x to the 3rd times 4x to the 3rd. I add the exponents, so the first term becomes 2x to the 5th. And then in the second term, let's see, 2 times 4 is 8, and I add the exponents again to get x to the 6th. Now the power rule says if I have an exponential expression and I want to raise that to another exponent, I can multiply the exponents. The power rule also tells us that if we have products or quotients, we can apply the exponent to each piece in that product or quotient. Now, I would like to point out there isn't a power rule for sums or differences. If you are adding something and you have an exponent, you cannot apply that exponent to each piece. We'll talk about what to do in this case a little bit later, The important thing is if you have a product or a quotient, that's when you can, in a sense, distribute or apply the exponent to each piece. So let's see how this works in some examples. The power rule says we multiply the exponents, so part A would be y to the 12th. In part B, the 2x to the third is actually a product, so we can take 2 squared and then x to the third squared. 2 squared is 4, and x to the third squared, I multiply the exponents to get x to the 6. Part C is a quotient, so I can also apply that fourth power to each piece separately, and I'm going to multiply the exponents again. That's where the a to the 8th comes from, and then in the denominator, 3 times 4 is 12, so over b to the 12th. Now we can use a combination of these rules together if we need to. So for example, in parts D and E, first thing I would do to simplify is get rid of parentheses. That's my power rule. So I multiplied the exponents, that third power, to get rid of the parentheses. To finish this problem, because it's a product, I'm going to add the exponents. 3 plus 6 is 9, so I have an x to the 9th, and 4 plus 15 is 19, so y to the 19th. Same idea in part E. I start by multiplying the exponents to get rid of the parentheses. Now that squared has to apply to the 3 as well, so I'm going to get a 3 squared. I'll turn that into a 9 eventually. But then I multiply the exponents, so to get the x to the 6, y to the 4th. Now I have a product. I'm going to rewrite that 3 squared as a 9, and then I'll add the exponents. 4 and 6 is 10, so x to the 10th, and 2 and 4 is 6, y to the 6. We're going to come back to the laws of exponents in a future section and learn about what do we do when we have division. But for now, we're just going to remember that if you're multiplying things with exponents, you add the exponents. If you have parentheses, that's when you multiply the exponents. For now, the thing that we're going to do with exponents is we're going to talk a little bit about working with polynomials. And I have in the notes an example of a polynomial. This is a sum or difference of terms that contain variables with exponents. The polynomial that I have written down is an example of a trinomial because it has 1, 2, 3 terms. We're going to call a polynomial with 2 terms a binomial, and a polynomial with 1 term a monomial. If the polynomial has more than 3 terms, we just call it a polynomial. Now we might also talk about the degree of a polynomial, and the degree is the largest power of a variable that you see. In the example I have in the notes, the largest exponent I see is a 3, and so I would say that this polynomial has a degree of 3. So in example 5, let's classify each polynomial and then state its degree. Part A is a trinomial because it has 3 terms. The largest exponent I see is a 5, so we would say this is a 5th degree trinomial. Part B is a binomial. It has 2 terms, the x and the minus 5. The largest exponent is technically an imaginary 1. That's an x to the 1, so this would be a 1st degree binomial. We're going to spend some time talking about different operations you can do with polynomials, but for now we're going to focus on adding and subtracting polynomials. Adding and subtracting polynomials is actually something we've done before, we just haven't used this vocabulary. If you want to add or subtract polynomials, you can only combine like terms. And that's something we learned about at the beginning of the semester. To combine like terms, we need to have the same exponent, and we just add the coefficients. So in example A, the 3x squared and the 2x squared are like terms. I add the coefficients, and the variable part stays the same. So I get 5x squared. Notice the exponents only change when you're using that product rule or the power rule, when you're multiplying. When you add, the exponents don't change. The minus x and plus 10x are like terms. That becomes a plus 9x. The minus 7 and plus 4 are like terms, and that becomes a minus 3. And that's my final answer. I have no other like terms. It's the exact same idea with subtraction, except you want to make sure that you're subtracting all of the terms in that second polynomial. So I usually take the time to rewrite the problem, but distribute that negative. So I just change the signs of all three terms in that second polynomial. Now that I've distributed the negative, I can add, I can combine like terms. Minus y cubed minus 2y cubed would be minus 3y cubed. Plus 4y squared plus 3y squared is plus 7y squared. Again, notice the exponents don't change when you add. And then I just have one term with a y, so plus y. And then just one constant term, the minus 7. I'll tack that on. That's it for this lesson. As always, let me know if you have any questions on this material.